Everyone, welcome to our machine learning lab report. Today, our group will walk you through how we collected motion data, processed it into features, trained a predictive model, and tested it to recognize human activities.
For the motion data collection process, we first set the phone sensor to a sample rate of 32 Hz. Next, we turn on an accelerometer and make sure to set the units to meters per second squared. In this video, you can see that I started the acquisition in a standing position, and then I lied down, and then ending that acquisition.
Goal was to build a model that could reach at least 75% accuracy across all 5 activities: brushing the teeth, drinking water from a glass, lying down in a bed, pouring water in a glass, and walking. To do this, we had to limit ourselves to no more than 5 features, because if we added too many, the model could start to overfit. We selected average acceleration x, y, and z, and average absolute difference x and z. These were the 5 features, gave us enough information to summarize the motion patterns while keeping the model simple. We used MATLAB to import the roc's accelerometer data, collected from a cell phone, and then applied the extract activity features function we had created to process the signals. This function calculated the chosen features from the unit by unit reading, transforming them into a meaningful data that the model could train on. We then trained the model using these features and tested it with new data. Our final model, Model 2.1, was able to correctly classify 87.3% of the activities, which is above our target. Looking at the confusion matrix built on the 370 different data entries, we can see that the model performs very well overall. From the training data, it got true positive reports more than 80% of the time for all activities. When we ran the model with our own collected data of the 5 activities, we achieved 4 out of 5 correct predictions. The one activity it struggled with was brushing teeth. This was likely due to human error while recording the data, since the brushing motion looked similar to drinking water, which confused the model, or these were signs of overfitting combined with human error. So, to summarize, we set a target of 75% accuracy across all activities, carefully selected 5 features, imported the raw data into MATLAB, processed the data into features, and then trained a predictive model. Our model 2.1 reached 80% accuracy with only minor confusion between brushing teeth and drinking water. In conclusion, this lab helped us understand the full pipeline of machine learning: collecting data, converting units, selecting features, training a model, and analyzing the results with a confusion matrix. While brushing teeth caused some issues, we still reached our target and saw how machine learning can successfully recognize human activities. Thank you for watching our presentation.